Hi, my name is Asad Ali Mirza and welcome to Narrative Learning. Today I'm going to give an introduction of blockchain. Before I talk more about blockchain, I want to give you a concept of what an open ledger is in a bank. So basically an open ledger is an open ledger where you keep records of your transactions. So you have some credit entries and you have some debit entries, and if you accumulate them then you will get a balance. So it's as simple as that. And you also have every record timestamp with a transaction code. So these are like different details based on different banks, but in blockchain you have a different dimension of the data, which I will discuss a bit later. But if you see the concept of open ledger, then you will understand that blockchain is no different from an open ledger. As I've been talking more about blockchain, let's take it apart and discuss it in a bit more detail. Consider this as a single block of blockchain. As you can see, there are multiple dimensions of this block. One of the dimension is the data block, which holds the data part of the blockchain. This could be any type of data. It could be a list of transactions, it could be a document that you can sign, or it could be any business related data. The second part of the block is the hash part, which holds the hash of the block data. The hash of the data along with its time span is calculated, and the resulting hash is stored in the hash part of the block. The third part of the block is the hash of previous block. By adding that, we ensured that the block is connected with its peer blocks. And also it knows the authenticity of the previous block. So if anyone tampers with the previous block, the hash of the previous block will be changed and we will have an inconsistent block hashes. In the process of forming a blockchain, the first block of the blockchain is called the Genesis block. The Genesis block is the very first block in every blockchain. In the structure of the Genesis block, the previous block field is empty as there is no former block. The formalization of the blockchain not only requires the Genesis block, but it also needs some rules to obey to add a block to the change. These rules are called consensus protocol. The consensus protocol of a blockchain dictates how the block is processed, which means how we are going to calculate the hash of the block. If any block is tempered, then the rest of the block in the blockchain will be invalid. The only way to invalidate a whole blockchain is to tamper with a block and recalculate all the later blocks. While we're talking about Genesis block, here is the Genesis block of the Bitcoin. As you can see, this is the first block of the Bitcoin. There is no previous block with no transactions to calculate. There is also a reward to calculate the hash in the block, which is 50 Bitcoins. Reward is a very good way of contributing to the currency, which is explained more in the concept of mining. Now that we know about the blockchain, what if someone tampers with a blockchain that is shared with all the nodes? So what will happen is that all the nodes will have an invalid blockchain. To deal with this problem, the concept of distributed blockchain is introduced. So each node in the network will have its own copy of the blockchain, and every change in one of the blockchain will be authenticated and synchronized with all the blockchain within the network. The distributed blockchain is still vulnerable with one famous security problem. For example, if you invalidate more than 50% of the blockchain nodes, then you have successfully performed a 51% attack and you have control of the network. You can rewrite the consensus protocol. You can manipulate the transaction history. So basically, you can even delete the whole data. But as you might have noticed, that it's really performance costly to perform such an attack on more than half of the network at the same time. So for now, it's really hard to achieve that, but theoretically you can achieve that. Now let's discuss the 51% attack in more detail. Consider this is your next network with multiple nodes. The blue nodes are the good nodes. Each of these good nodes have their own copy of the blockchain. The red nodes are the bad nodes with malicious intentions, and they have a valid copy of the blockchain as well. The bad node then publish a malicious block to the network, and synchronously do that with all the local blockchain of the bad nodes. This will in return publish the same block to all the nodes in the network. The good nodes will also receive the same malicious block. There is a chance that they will invalidate the block, tagging it as malicious block. But as you can see, the major nodes in the network have accepted the malicious block to be part of their valid blockchain. And the good nodes will think that their blockchain is invalid as they are less in number, and they will synchronize with the bad blockchain. So now the whole network is infected, conducting a successful 51% attack. The 51% attack looks really simple to conduct, as all you have to do is recalculate the hashes of the blockchain, and then you can invalidate the whole blockchain with enough CPU power. To address this problem, there is something called proof of work. The proof of work dictates that you can recalculate the hash, but there are certain rules that are applied to the hash. The hash should have some particular number of zeros, or it should start with at least X number of characters or numbers. So in our example, as you can see, there is a hash, we have a key, but we also have a rule which dictates that there should at least the starting 4 digits should be zeros. And that is something that we call difficulty. By introducing such rules, the process is generating the hash becomes more difficult and more CPU time consuming. So you try different key combinations until you reach an acceptable block, and then you publish that block with the key so that other nodes in the network can validate your work. The rules for proof of work are different in different currencies. Bitcoin accepts one block every 10 minutes, with some difficulty, of course. Intensecoin accepts one block every 30 seconds, and it's different for different coins. The difficulty could increase with time. The more difficulty, the harder it is for the attacker to stage a 51% attack. Let's say if I'm one of the node, what will I get in return for processing power that I'm contributing to calculate the hash in the blockchain? Should I get something in return? There are special nodes who contribute in processing of the blockchain called mining nodes. The concept is called mining in blockchain, where we pick up a block, we calculate hash on that block using a key until we reach the difficulty, and once we have that, we have calculated a successful hash. We can say that we have successfully mined the block, and then we publish it to the blockchain. You get reward in return of mining, which is also called, or also in the form of the currency which you're mining, which helps in building the blockchain, and it also contributes to the currency. Mining is a process of running your rules. It keeps your network stable, safe. It helps securing the process, validating and invalidating blocks. But the problem with that is that it doesn't have a bright future in many currencies because it takes too much electricity. It takes too much power to calculate the hash. So maybe mining is not the future. There are some alternate solutions which I will discuss later. So in this lecture, we have discussed a single block in blockchain. We have discussed distributed blockchain. We touched 51% attack. We saw how proof of work works. And we saw how mining in blockchain works. With that, I'm going to end my lecture. If you have any comments or questions, don't hesitate to email me. My name is Asad Ali Mirza, and this is Narrative Learning. Thank you for watching.